An unusual event is taking place on Betelgeuse's surface, Orion's red supergiant star nearing its end. In December 2019, the star gained attention when it began to dim unexpectedly, reaching a historic low in brightness by February 2020. This phenomenon, later called the Great Dimming of Betelgeuse, although it returned to its usual brightness that year, intrigued astronomers, leading them to use powerful telescopes for a closer examination. What they found was astonishing. The star's surface is boiling, creating a cosmic illusion. Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. Betelgeuse is significant. It's among the most fascinating stars visible at night. It originated in a stellar nebula and spent 90% of its existence in the main sequence phase, converting hydrogen into helium in its core. However, with a mass 15 times that of the Sun, Betelgeuse followed a different evolutionary path. Instead of becoming a red giant like typical Sun-like stars, it transformed into a red supergiant. Betelgeuse's visibility during its final evolutionary stage makes it a valuable subject for studying the processes leading to supernovae, one of the most violent stellar events. The last major supernova in the Milky Way was Kepler's supernova in 1604. Since then, no supernova within the naked eye's visibility has been observed in our galaxy. Thus, any significant change in Betelgeuse is noteworthy. Even when Betelgeuse's brightness decreased, astronomers speculated that this might signal an imminent supernova explosion. To explore further, they used the Atacama Large Millimeter Submillimeter Array, ALMA, to monitor the supergiant. ALMA's observations revealed the star spinning rapidly, exceeding predicted speeds by current physics laws. This was puzzling. Why is Betelgeuse rotating faster than other stars of its age? Could this rapid rotation indicate an impending supernova? Just as a supernova triggers cosmic reactions, learning a new language sparks dynamic brain activity. Introducing Babbel, a top language learning app. Learning a new language with Babbel can be transformative, helping avoid embarrassing lost-in-translation moments. For example, I once tried to impress Spanish-speaking friends by saying, "I love the beach," but mistakenly said, "I love the shovel." They couldn't stop laughing. Babbel helps prevent such mix-ups, enabling you to start speaking a new language in just 3 weeks with lessons from real teachers. You can also join live classes. Choose from various plans, including a lifetime subscription with a 20-day money-back guarantee. Viewers of this channel get 60% off their subscription by clicking the link in the description. Let us know which language you want to learn in the comments. The first clue of unusual activity on Betelgeuse came from its surface radial velocity map, provided by ALMA. This map visually represents the speed at which different parts of a star or planet move toward or away from an observer, using colors to indicate motion, speed, and direction. ALMA's observations showed one hemisphere of the star was blue-shifted, moving toward us, while the other was red-shifted, moving away. Crucial for accurately measuring rotational velocity. Comparing these results with Hubble Space Telescope observations confirmed Betelgeuse's rapid rotation. Theories suggest Betelgeuse's high rotation might result from once being part of a binary system, absorbing a lower mass companion star, known as celestial cannibalism. While not uncommon among red supergiants, there's no conclusive evidence for Betelgeuse. If Betelgeuse evolved as a single star, its fast rotation significantly deviates from predictions. To understand why Betelgeuse's fast rotation is problematic, consider its size. Betelgeuse is 15 times more massive and about 1,000 times larger in diameter than the Sun. If placed where the Sun is, it would engulf Earth and extend to Jupiter's orbit. As a red supergiant, Betelgeuse has expanded and cooled, which, according to the conservation of angular momentum, should slow its rotation. Moreover, mass loss through stellar winds also contributes to decreasing rotational speed. Current theories propose red giants rotate around 1 kilometer per second, and red supergiants like Betelgeuse even slower, typically less than 0.1 kilometer per second. Yet Betelgeuse rotates at 5 kilometers per second, 50 times faster than expected for its category. To solve this mystery, astronomers needed to confirm if the observed rotation was real or a measurement error. They considered other surface activities possibly misinterpreted as rotational movement. Using ALMA, consisting of 66 advanced radio telescope antennas, astronomers examined Betelgeuse's outer atmosphere hot gas. They hypothesized that Betelgeuse's rapid rotation might be mistaken for surface activity called convective flow, moving heat in stars like Betelgeuse. In convection, hot material rises to the surface, while cooler, heavier material sinks, creating large swirling patterns or convective cells like giant boiling bubbles. These patterns can extend deep toward the star's core. Researchers theorized these boiling bubbles might create an illusion of rotation, with bubbles rising on one side and sinking on the other, mimicking star rotation by causing parts to move towards and away from us. This movement could explain ALMA's blue-shifted and red-shifted regions. To test this, researchers created a computer model of a non-spinning red supergiant with a boiling surface like Betelgeuse. Comparing the model with ALMA's observations, the simulated star matched the real data perfectly, confirming the theory. Thus, Betelgeuse's surface bubbling creates a strong illusion of rotation. This study adds to Betelgeuse's unpredictable behavior history, not new for astronomers. The Great Dimming 4 years ago was explained by a large hot gas expulsion, cooling to form dust that temporarily blocked the star's light, making it appear dimmer from Earth. In 2023, Betelgeuse exhibited another odd behavior, a 50% brightness increase. Initially thought to signal a supernova, further analysis revealed it was an after-effect of the 2020 Great Dimming. The dust and gas released during that event disrupted Betelgeuse's brightness cycles, typically 400, 185, 230, and 2,100 days long. The Great Dimming shortened the 400-day cycle to 200 days, causing the unexpected brightness increase. Predicting Betelgeuse's supernova timing is complex due to difficulty determining its exact life cycle stage. Scientists need to know if Betelgeuse is in the helium or carbon burning phase. At 550 light-years away, we are well placed to witness this cosmic event. When a supernova occurs, the first clue would likely be a neutrino surge, tiny particles emitted in vast quantities during such explosions. The Supernova Early Warning System, SNEWS, uses neutrino detectors to look for these early signs. Following the neutrino burst, a supernova would release tremendous energy, visible during the day for about 2 to 3 months before fading. Although a Betelgeuse supernova would be spectacular and pose no danger at its distance, it would change our night sky. Betelgeuse, one of Orion's shoulders, would be missing, with the explosion remnant invisible to the naked eye. Some ask if we can study Betelgeuse with the James Webb Space Telescope, JWST, to predict a supernova accurately. The answer is no. Webb, though powerful, is unsuitable for observing Betelgeuse. It's designed for distant and faint celestial objects, but Betelgeuse is about 1,500 times brighter for JWST's sensitive detectors, making it impractical for this purpose. If you learned new things from this video, like it and subscribe to our channel. Check the description link for a special Babbel offer. Thank you for watching and see you next time.